The world is almost ending. Yeah, because like this, if it continues like this, hey, yeah, there's not been any sun today, and now the temperatures have really dropped. Yeah. Anyways, welcome to today's session. Yeah. And welcome too early for coffee. Let's do a recap of what we did last time, and then we build on that. My goal is we build on the idea of collections, and then we bring in iterators, and then from there we'll be able to use existing collections within the JDK. So maybe if you are there on the previous session, it would be nice to ask if you have any. It's been like maybe 4 or 5 days or something, maybe 4 days. If you have any questions, something you didn't understand, you can ask before I do the recap, or if there's something that we did and you want to comment on it. I think this would be a good time. Okay. Otherwise, you guys know the drill. You feel free to interrupt me. If you can't, you can also leave just type a message, and we'll be able to. I'll be able to proceed. We'll be able to proceed with that. So another new thing is I'm attempting to do this together with YouTube live stream at the same time. So we'll see how it goes. The idea is if I do it on YouTube live stream, I don't need to record and I don't need to edit. And the whatever we'll have covered during the session will automatically be available for you to go back and revisit. So I don't know. I'm using OBS to do the YouTube stream. The first time, so I'm completely lost. But what I'll do is after the session, I'll share the link to the resulting YouTube video from the stream itself, and then if you want to go back and revisit what we've done, you'll do that. If it works out really nicely, then we could be doing that, and that removes the burden of having to record and all that. But I'll share the link after this. So let's go ahead and start. So last week we created this freezer collection, which was our first collection, and we created it by implementing the collection interface. And we were able to implement some of the methods within the collection interface, abstract methods. We're able to implement size to give you the size of the collection. We're able to implement this isEmpty method that checks whether the collection is empty. And we're able to implement contains, which just checks whether the element you're looking for is contained in that collection. And we were able to skip some of them, like the iterator, and we learned about this facility of unsupported operation exception, which is an error that you can initiate if somebody tries to do something with your implementation that you don't support. So this is really good general knowledge. Anytime you're implementing an interface, know that the caller of the interface is expecting that you've implemented all the abstract methods, but if you're not in a position to implement the abstract methods, you can always give them an unsupported operation exception, which is just an error telling them, hey, this thing you're trying to do, I have not implemented it, so don't try to use it within my implementation. Otherwise, we saw all the implementations that are required for you to have a valid collection implementation, and we were able to put that into practice with our main method here. We had an array of ice cream flavors, and we were able to put that array of ice cream flavors into our freezer collection, and we were able to do several operations with it, like checking whether it's empty, checking the size. We were able to check whether it contains a particular flavor, a random flavor, and so on and so on. We also did this to array function. So today, the first enhancement I'm hoping that we're going to do is we don't have any reason to limit our freezer to storing only flavors, ice cream flavors. You know the way, if you have a freezer, you can put multiple things in there. So apart from ice cream, you can have popsicles. You can even have maybe water, drinking water. Maybe somebody likes it ice cold. Maybe it's a very sunny area, so if you're able to keep some really cold water, somebody can come in and be able to access it. Or you can have different types of ice cream flavors, but generally this collection of ours doesn't need to be limited to flavors. Essentially, we can be able to have it store multiple things, just like freezers in real life. So the way we are going to do it is by going back to what we learned in generics, and we are going to make our freezer collection a generic object. In our current implementation, our freezer is not really generic. In fact, it's not generic at all, because it is storing one type. It's handling one type, which is flavor. And the way we are passing that information back to the collection is we are saying this will handle an object. But using generics, we can make this freezer collection, first of all, be able to handle multiple types, not just flavor, but also we can implement the interface in a way that specializes all the operations to that type that is specified by the caller. So if a caller creates this and says, I want to use this to handle ice cream flavors, then these collection functions will adapt to that specification. If somebody creates this freezer collection and says, I want this to handle maybe water as well, and you have a water data type, then the implementations of the abstract function from the collection interface should be able to adapt to that, just like we saw with the examples we were doing in our previous generics classes. Okay. Okay. So I hope everything is going well with the YouTube live stream. I don't know how to check. So we'll see after. Anyway, so let's focus on this. So what I want here is, I don't want this to this whole freezer collection to be limited to flavors. So anywhere there are flavors, we'll replace it with this type T, which is whichever data type that is provided. So anywhere we have flavor, we'll replace it with the T. So we have it there for flavors. In fact, I think it would be nice also to refactor the naming. So I'll go to refactor, then rename, and we'll rename this to elements. So I'm just using the IDs that most of it can be renamed automatically. So you'll see anywhere there is flavors, it has been renamed to elements. And now, anywhere we have this flavor object, I want it to be T instead, which is a generic type. Of course, we'll do a lot of refactoring for us to be able to support this properly. But essentially, that's what we want. So so we have object here. So another thing is, so we've specialized it to T, and how we make this freezer collection a generic class is we add those brackets like we did in while doing generics, and now we can pass this type to the collection as well. So so the collection interface, the implemented abstract methods will also be expecting generic type T. So we've said for this freezer collection, it can store any type, type T, that will be determined by the caller in main. And the collection interface, or because we're implementing that interface, we are telling it, since it's generic, its abstract method should implement should also use the type T that is determined by the caller of this interface. So the creator, the caller of this class, the implementation of the class. I think the right word is instantiation. We'll see that when we go back to our main method. So now when we do this, we see that the freezer collection, so this is okay. So now we have elements of an array of elements of type T, and you can pass that in the constructor, and we use it to populate the elements. The size function works well, is empty works well. So where we have problems is in the contains function and in the iterator function. So since we've changed this from just from the collection having a parameterized type of object to a parameterized of type T, parameterized type of type T, then whenever we are doing implementations like the iterator implementation and even this, we need to change that to T. So we receive elements of type T, and the same with the iterator. We'll use T there. The toArray function, we can attempt to use T as well. All of these functions that are using object, we need to replace them with the new type signature that we are using here. I think that's all of it. Oh yeah, then there's that, and yeah, that. So other elements in this case. So I'm seeing some errors. Of course, we'll investigate those. So with the contains, so with this contains, it's saying method does not override method from its source. So whenever you see this, you can just check and see how the collection interface might want us to implement that. But also we can just go to the interface and investigate. So the function we're having problems with is this contains function. So the contains function, it's limited to object. So you'll see with the iterator, they've specified that it can use the parameterized type, but with the contains, it always uses object. So with that, we cannot specify it to work with our parameterized type T. toArray, we see it's returning an object array. So I suspect even with this one, we won't be able to return an array of elements of type T. Let's see the next one here. So this one works with the parameterized type, so that should be okay. But the type signature seems to be different. So yeah, but that should still work. This other toArray as well. So this one allows generics, but yeah. So where we're getting errors, not all the abstract methods in the collection interface support the generic type signature that we are trying to use. So some of them will have to use object, and it might make sense in the way the methods are implemented. For instance, with the contains, we are receiving an element, and then we are trying to check whether that element is contained in the array that we are wrapping within this collection. So the ones that don't support generics, you can just return them to object. So that. And the ones that can work with generics then can be, you can use the type T for them. Of course, we'll still have to do refactoring for some of that. So it seems even this remove one, we'll have to use object. So the interface itself does not support generics for that function, so we have to still use object. And I believe this toArray one, we could use object with it, but we can just look at the specification and see toArray. So there's this toArray which is a default method. It receives something that we haven't covered yet. So ignore that one. We are definitely not using this. We are using this one, I believe. So where we are receiving an element, an array of elements of type T, and we are returning that element of arrays type T. So with this, I think that's the one we are using, and in our override function, it seems to not be the right implementation. So what we can do is you can try to regenerate it, and I can see it's a bit different. And since we are doing unsupported operation for it, and it's not a function that we are supporting, so I believe this one we can ignore. So with that, I'll just throw, just like we had earlier, we can throw unsupported operation exception for that implementation. Otherwise, it has some unique signature here, but we can just focus on these other ones. You don't have to dwell on it. So with that, I think the only function that we still need to refactor is this contains function. So looking at it, we are receiving an element, which is an object. That means it can be any object. And previously we saw that we could use instance of to check whether it's an element of the instance of the type we are working with. And if that cast failed, then we would return false. Otherwise, we would go ahead and check for a specific property. So now that our type here is generic, this candidate.name will not work because our type is generified and it's not bounded. It's open. We've not said. Remember with the numbers example where we had a type that extends number, and then since we've specified that the bounds are within number, now you can access functions within the number interface. With this, we haven't limited it to flavors or some other type, so it's unbounded. So you cannot call functions on it like we are doing here for checking the name. So temporarily, I'll comment it out. So this is one function that we are not able to support yet. So I'll just comment it out. We'll come back to it, and of course, you might already guess that we'll add bounds for so that we can be able to support that operation. So for now, we'll just add the unsupported operation error, just telling the caller that we are not able to support this function. So with that, our refactor is completed, and now our freezer collection is of generic type, and it can handle theoretically any type of elements. So it can handle integers, it can handle flavors, it can handle doubles, it can handle strings. Anything you throw at it should be able to handle. Of course, limited by some of the operations that we are not supporting, but some of the operations we're able to support. So now if we go back to our usage, you notice that not much has changed here. So we are still able to create a new instance of this freezer collection, and we're able to pass in ice cream. So the only thing we are getting from the IDE is raw use of parameterized class, which is, this usually means you're using a generic class, like in this case, and we have not added the type signature. We've not told it, yes, this is generic and it only works with this. We are specializing it to work with this particular type. So in our case, we are working with flavors, so we can say we can add that type signature there, and you'll see that warning will disappear. Okay, yeah, you'll see that warning will disappear, and this ensures that the freezer collection. So this flavor type signature we've added here, if you remember from the class, from the generics class, it will replace T. So when you specialize it like that, so now that instance works with flavor. If we wanted to work with something else, we wanted to store something else in this freezer, We can have a freezer that stores, let's say, labels. So for whatever reason, this freezer only contains labels. So we can create an instance of the same freezer collection and say this works with string. And here we can pass in an array of string. So you can pass in a string array there, and this string maybe has label 1, it has label 2, and so on. And that is a valid instance of the freezer collection. So you can see how this freezer collection now has been extended to support multiple types. The same way you can have a freezer that perhaps stores a different type. Let's say it stores integers, in this case. In fact, let's try and make it a bit more interesting and have going to create, so this flavor was a record. So you can create another record, and this record is, let's say, water. Not a very realistic example, just to see how you can be able to manipulate multiple objects, multiple object types. So this water has just one property, which is temperature. And now if we go back to our main method, we can say we have a water freezer that only stores water and stores water in different at different temperatures. So the same, we instantiate the same freezer collection, and we can say this one only stores water. And now we can say this has an array of water elements. And just like we did with the ice cream flavors, we can have new water, and we pass in a temperature, and we can have multiple instances. Like so. Okay, so it's not very clear here. Let me just create that list above so that it's clear. So it's an array of waters, if there's anything like that, and this stores waters. And I'll just move this here so that it's easy to read. And of course, now we can just pass that to this constructor. Okay. Yeah. So you can see we have the same freezer collection handling flavors. We have the same freezer collection handling strings. We have the same freezer collection handling water and any other type, integer, double, whichever. So since we want our freezer to be one freezer that stores multiple types of things, but we want to create a bound for those things so that we can start to support specialized operations like this contains function, what we can do is we have this flavor record. I'm going to create so we can create a superclass just like we did, or even an interface that is implemented by multiple classes. But let's use the superclass version. So we'll create a superclass that defines the things that can be stored in the freezer collection, and then we'll use that superclass to limit the bounds of that our freezer collection, so that it's not unbounded. The freezer collection has a clear idea of which elements can be stored here. Essentially, what we are looking for is being able to say, yes, any type T, but that type T must extend a certain super type, so that we can be able to have specialized operations like the contains function, which actually checks the properties of the the objects that are being stored inside this collection. So if we limit it to maybe flavors, for example, we're able to call this name property in the flavors. So if this was limited to, for example, flavor, I would be able to call this name property. Let me just show that before we create the superclass and the hierarchy. So you see now, yes, candidate T, still type T, but now we have the candidate is of type T, but now we're able to call name function, which name function is being inherited from a flavor, which is that name property. So we can obtain the name property, and we can use that to compare with whichever value we get here. So in fact, if we are doing instance of, we could do that, and that would work okay. And also, since our T is specialized, we could also do, I think, okay, so object cannot be safely cast to T. So here we have to use a very specific type. Yeah, I was hoping we could use the T to do the casting, but it seems there's some limitation. But I'm sure we'll find some way around that. But bottom line, what you should be able to observe is with the candidate T, we are still able to limit it to a specific bounds, and we can use those bounds to do specialized operations. So let's create some inheritance hierarchy. We can build that inheritance hierarchy around flavors, which would actually work. So we can have flavors, and then we have several ice cream flavors already implemented, and passing those ice cream flavors. Yes? Is anybody asking a question or commenting? Okay. Yeah, so we can build an inheritance hierarchy around this flavor. So what I'm going to do is, so we have flavor here, and I think last time we noticed that we observed that with the records, inheritance is not very well supported. I think our expectation was that we could have a record that extends another record, which was also my expectation. But inheritance not well supported there. So what I'm going to do is I'll convert this into a class, and I'll set this as, so yeah, we'll be losing some convenience, which is which comes with the records, but no worries. So it will still have the same one property, and this one property is the one we'll be using for comparison. And since it's a class, we'll have to have perhaps a constructor for it. So let me create a constructor flavor. And this constructor just, it can be a no-args constructor, but we could use it to, let's just have one that we use to initialize the name. So let's say this dot name is equals to that name, and we can have our setters and getters. So we'll have a setter for name, and we can have a getter for the same property. So now with this, we can go ahead and write the classes that in fact, we can even have one class that inherits from this, but for demonstration purposes, let's have like 2 or 3 of them. So one class we're going to use is ice cream. Of course, ice cream has a flavor, so we can utilize that. So I'm going to create a class ice cream. And what you're going to say here is this class ice cream extends from flavor. There's no, okay, no. So we still we need to have a no-args constructor. I think we need to have a no-args constructor on the flavor itself or on the ice cream. Let's see. Yeah, so this has to have a no-args constructor. No worries. I think we can use that, or we can have a caller to the superclass of this. let me try the alternative option, which is instead of having a plain noargs constructor there, let's try to have a constructor for our ice cream class, and inside this constructor we can call super, and of course a super will require us to pass in flavor, just testing with that. So this ice cream has to receive flavor somehow. We can make that an instance variable of this ice cream, or we can just pass it down as a property. Let's call this flavor name. Flavor name. So when you instantiate ice cream, you pass in a flavor name, and that flavor name will pass will be used to as the property for the superclass flavor, that name property. So that's ice cream. The other thing that might have flavor is maybe popsicles. Popsicles. How do you spell popsicles? Popsicle. I don't know how to spell popsicle. Popsicle. Okay, popsicle. Yeah, this one. Ice pop. Popsicle. So we have popsicle. It's LE. And with that, so popsicle can also extend from flavor, and just like the other one, we can have that public constructor, and we can call super and pass in the flavor name. So these are two things that we are sure have kind of share the same properties in that they have a flavor. Just so that we don't confuse it with the property in flavor, we can do that. So with the same with popsicle, you pass in flavor name, and that will be used as the name, since we are calling. So when you call super, you're calling the constructor for flavor. So now we have two. I think we can use those. And now if you go back to our freezer collection, we said that it handles anything that extends flavor. Oh yeah, we changed this from a record to a regular class, so now we cannot access this property in this way. We'll have to use getter. So for get name, the same here. Although we'll be able to we should be able to fix that, but essentially we need to ensure this is of type flavor. Yeah. But we'll get back to this. But this is just a change of from the record to a class. So what I wanted to show here is in our initial instantiation. Let me remove the ones where we have these other instantiations, and let me get rid of water because we are not going to be using it. Yeah. So with this, so we have the ice cream, yes, and we're able to specialize it to a flavor, but now since it's ice cream, let's make it ice cream for it instead of flavor. So here we'll create an instance of ice cream, and ice cream list. So just a name conflict, I think. So new ice cream and flavor name, and I bit of a mistake there. So yeah, so that should be that, and we can replace the names here. So we can replace the names, and now we are creating instances of ice cream, and we can pass that ice cream list to our instantiator. So the same, we can say, okay, this one stores ice cream. So although a flavor would still work because ice cream extends from flavor, we can specialize it to that, or we could even specialize it to something else, but like you saw with the integer and the string and the water example. So you'll see most of the other functions will be able to work. Of course, here we'll need to use a getter. But now we have a generic freezer collection. So the only function we have trouble with is this contains, because as much as it works as it is currently, it would be good if we didn't have this flavor specialized here. But since we are using it in the type signature, I don't think it's too much of a problem to have it there. But it's good to know that at least that T will not work for it. So it can't check the type there to know that will inherit from flavor. So with that, our contains function should be able to work. So everything we did last time should be able to operate the same way, except this time we can work with ice cream, we can work with popsicles. In fact, let's do one with popsicles. So let's create a popsicles array, and this is popsicles, and of course is equals to now that popsicles array, and need to remember to terminate, and there just pass in the flavor name. Let's have like 3 of them is fine. So here I'll use colors to represent flavor. Just know that what we are passing in is the flavor name. And now with the popsicles, you can create a freezer that has popsicles, freezer collection is equals to new freezer collection, and this freezer collection works with stores popsicles, and we can pass in our list of our array of popsicles. We call this ice pop freezer collection. So we can see that we're able to specialize that. Interesting thing, just a callback to generics. Let's try and create an integer freezer, just to see what will happen. One that stores integers. So freezer collection, integer, and we pass in integers. I'll create an array of integers. Integers is equals to new integer, and here we just have a bunch of integers, 3, 4, 5, 5, 8, and we pass it in. So you will notice we have an error here, and the error is type parameter integer is not within bounds, should extend flavor. So since we specialize the collection to only handle elements that extend any types that extend from flavor, any other type that we pass in here that doesn't extend from flavor, you'll see ice cream extends from flavor, popsicles extend from flavor, all the other types will not be supported. So yeah, so we could run some of these things we were doing, some of the stuff we were doing with the freezer collection last time, and see whether we're able to still get those operations work. So we have freezer empty is false, of course, because it has these ice cream instances. The number of flavors is 5, so 1, 2, 3, 4, 5. Then we're able to create a copy of flavors, and the copy of flavor was the strawberry. So this is empty. The function is what is giving us this. So it's able to check is empty. We're able to call size and obtain the number 5. we're able to check whether it contains a particular element, and you can see that it's able to do that. And even this element can be ice cream. You can tell it, check whether it contains this ice cream called Bluey. And I think it's able to check, contains, so we'll see that ice cream is out of stock. So there's some things happening here because of how we are printing it on inside our collection interface. So you can change that, but essentially you can see that it's able to check. So if we check for something that is present in the collection, like vanilla, and I hope you guys are not lost because we did this example last time. I'm just modifying it to add a bit more of a generics flair to it. So you'll see is in stock, which means it was able to find that vanilla. So any questions about the change we've made to the freezer collection? Are we in the same page? Okay, I'll take the silence to mean we're in the same page. Preaching to the choir. Okay, so let's do the other thing that we are supposed to do for this session. Otherwise, just remember you can specialize your collection like that. So the other thing we didn't have in our collection was an iterator. So we need to create an iterator. I remember last time we discussed what an iterator is, and an iterator is just a way for you to loop through your collection. So what we're going to do is create an iterator for our freezer collection. And the way we do that, again, the same way we are implementing collection, the Iterator interface is available for us to implement. Let me see if I can find it with the IDE. Oh, in fact, I don't need to. I can just click on this. So we'll be using this interface, public interface iterator, to create an iterator that we're able to use to loop through our freezer collection. And the way we are going to do that, we discussed some of these methods last time, but let's do a recap. So there's this hasNext method, and what the hasNext method does is it allows you to check whether there's an element still in the collection that you can loop through. Imagine it like a box. Each time you are reaching your hand in to pick something, but before you reach in to pick something, you first check whether the box contains an element for you to pick, like a ball for you to pick. So that's the purpose of hasNext. It just allows you to check whether there's another element that you can pick from the collection. Then there's this next. These two are the most important ones. So what next does is it actually picks that next element. And you can see it's returning generic type EE, which is the element that is stored inside the box. So hasNext checks whether there's an element, next reaches in and picks that element. So those are the two main functions we'll be using. There's this remove function. We can decide whether we want to support it or not, and this one we will not discuss. It's in the next class. It's in some other class in future. So for now, we are going to focus mainly on hasNext and next, and potentially we could focus on remove, but unlikely. So another thing you'll see here is we have these default methods. I believe we discussed this when we are doing the interface recap. So you can see there's a default implementation for remove, and what it's essentially doing is it's saying that operation is not supported. So if you attempt to do remove, without overriding that remove function, it will just crash your program. And also we have another default method, which is this for each remaining, that you can imagine. For now, it's not there. Don't think about it. It will not be relevant until multiple classes down the line. So let's create our iterator, because we need a way of looping through our ice cream list. Any element that's stored inside our freezer collection, we need a way to loop through it. So we are going to create our iterator. Let's call it freezer iterator. And our freezer iterator can only be an iterator if it implements the iterator interface. And also you can see the iterator interface supports generics, so we can pass in a type signature. So the same way we did with collections, you can say this iterator works with T, and T is any type that extends flavor. It can be anything for your case, and you can say iterator uses that T as well. So now when we implement the functions from iterator, the ID keeps doing that. When we implement the functions from iterator, they will have that T type signature. So there's a few ways you can do this. We know the functions we need to override, so you can even just type them in. So we need has next, and we need next. And you can see this next function is now having this type T. So if I was using a different symbol, this is just convenience of the IDE. If I was using R and I had R there, if we did next, you'll notice it has R, and of course if we have has next just returns a boolean telling you whether there's a value in the box or the box is now empty. So you can see it's checking that and using that as the signature. And if I try to use a different symbol here, you'll see we'll have problems because it needs to reference that parameterized type. Okay, so now we need to implement these functions, but before we implement them, let's understand why we are creating this freezer iterator. So we are creating this freezer iterator because we want to use it where? We want to use it here. We want to use it for this iteration thing. And if we successfully create one, instead of throwing unsupported operation, we can just return new freezer iterator, like that. So that will be a qualifying iterator that we're able to return from this. I would probably, I always like to push the bounds of this to see whether you can do some things. Doing T there, okay, it doesn't have much of an effect, but it's just interesting. That's able to accept that T. But anyway, essentially what we are creating is a new instance of freezer iterator and returning that as an iterator. So notice that the iterator function does not have freezer iterator as the return type. It doesn't have freezer iterator as a return type, but despite being iterator, it's able to accept that freezer iterator as a qualifying return type. The reason why it's able to accept it as a qualifying return type is because freezer iterator implements iterator. So it implements the iterator interface. So if whichever iterator you have within your program, as long as it's implementing that interface, the Java is able to assume that it's a qualifying implementation. Because if you implement the interface, you have to override has next and next. Therefore, returning that as a value here is no problem. It qualifies as an iterator. And you see, even when I changed it to now return freezer iterator, there's still no problem because freezer iterator implements iterator, therefore it's an iterator. So it's the same thing essentially. So we want this and we want to access it. So let's make sure first it qualifies by implementing these functions. So for now, if you call has next, it will always return false. If you call next, it will return null. So that's not great. So first we need to give it something to iterate over. So we're going to create an array of elements, just like we did on the other side. And these elements will be of type R, and I'll call them elements. And I want to always have them because I would hate to iterate over an empty thing or a null array if there's anything like that. So I'd want anybody who creates a new instance of this iterator should always pass me at least a list of these elements. So that's the advantage of using this final keyword. So now I'll say this constructor will receive an array of elements of type R, and we'll use that array of elements of type R to initialize the elements. But let me use different names here, values. So the values will be used to initialize the elements array that we are working with here. Now, hasNext. hasNext essentially checks whether we have a value. And for us to do that, we need to have something that is checking the position of iteration. So let's imagine that elements has, let's imagine it's just a few numbers. Let's use numbers. So let's imagine elements has numbers 1, 2, 3, 4. And what iteration does, it moves from 1, checks 2, checks 3, checks 4. And when we get to 4, when you call hasNext, we should be able to detect that there is no 5 and return false. Otherwise, if you're at index 0 and we check, we'll tell you, oh, there's 1 is still available, 2 is still available, 3 is still available, 4 is still available, and now when we check the next time, we return false. So we return false when you've reached this point, end of the end of your array. When you reach the end of the array, you return false. Otherwise, before you reach the end, you return true. So you need a way of tracking that index. And the way you can do that is within this class, you can have a global variable. And our global variable here will be, it can be of type int, because we're working with arrays. And let's call this a counter. So arrays are 0 indexed, so we can begin at 0. And now what we'll be doing is just as if you call hasNext, we update this counter, and we use the counter to obtain the element at that index. So back to just a bit of recap of arrays. So the way arrays work is you have the element, for instance, this can be A, and you have the index of that element. So starting with 0 index, like that, you can have another element B, and its index will be 1. You can have another element C, and its index will be 2. You can have another element D inside the array, and its index will be 3. And this will be an array that contains, so this will be an array that contains 4 elements. So it contains A, B, C, and D. But the way you reference those elements is using their index. 0 is the index for A, 1 is the index for B, 2 is the index for C, and 3 is the index for D. So that's how we look through an array. Although this was, I believe, was covered, so again, I'm definitely preaching to the choir here. So what we're going to do, whenever you call hasNext, we hit our array. So an array usually has this nice utility method called length. So this gives you the total size of the array. And what we can check is if the position of the counter, if it is greater than the length of the array. Of course, we can refine it. So if it is greater than the length of the array, then we don't need to waste time. Return false. There is no more values. We've reached the end. We move from 0, 1, 2, and now somebody is passing in index 5, and we don't have index 5, so we can just return false. Otherwise, we can continue with the execution and say, okay, so this counter seems to be valid. So now we can, in fact, here we can return true. But another thing we might need to do is increment this. So we can increment it here, or we can increment it here. So just to see if we are together, where do you think we should increment this? Because essentially, whenever you pick an item, if you pick the first item, we are supposed to move it from index 0 to index 1. Then we move it from index 1 to index 2, and so on. Where do you guys think we should increment this counter? Should we increment it in has next or in next? Because, like I was saying, the difference is has next checks, next actually retrieves the value. Where do you guys think we should increment the index of the array? Anyone? Okay, Dennis says next. Anybody else want to chip in? Anybody with a different opinion or the same? Anybody who is lost and who wants clarification? Okay, let's go with Dennis' suggestion, which is to increment it here. So here we are just checking, and if counter is greater than the length of the array, we return false. We don't have any more elements. If not, we return true. In fact, we could make this explicit and say else return true, saying, yeah, we have some elements for that that are beyond the index you've passed. So here, within next, what we can do is now fetch the element. So here I'll say r next. Should I call it? Let me call it next element. Oh no, next element might be confusing. So the element that we are trying to retrieve, let's call it just element, is equals to elements at the counter index. Maybe to make this more explicit, let me call this index. Let's rename that variable to index. So obtain the element at the index, and that is the element we'll be returning. After you obtain the element, increment the index. So there's a few ways you can do increment in Java. One, you can be very explicit and say index is equals to current index plus 1, because we're just increasing it by 1. But there's shorthand for this, which is index plus equals 1, or you could do index plus plus, which these ones are usually a bit confusing because there is also plus plus index, I think. So you need to know the difference between the two. And within the software development community, it is discouraged to use this. And the reason why it's discouraged to use them is because how non-explicit they are, and also how it is very easy to confuse them. If you do index plus plus, it means so there's post increment, pre-increment, and pre-increment. So this is a post increment operation. So do the operation, then increment. This is a pre-increment, which means increment, then do the operation. So in our case, it might not have too much of a consequence because the only operation we are doing here is to increment it. But personally, I would discourage you from using this, and instead, if you're looking for shorthand, you can use this. And this shorthand supports multiple types of operations. You can even do multiplication, multiply by that. And what this means is just index is equals to index plus 1. And what this other one means is just index, the new value of index is equals to index times 3. So they are a bit more explicit. And in terms of positioning, the pre-increment and post-increment, now you're able to position them inside your code more explicitly. Like this one, we are putting it after the element has been retrieved. There is a very big consequence if we put it before the element has been retrieved. So if we increment here, creates very different results as to oppose to incrementing here. So yeah. So if you increment here, the index will move from 0 to 1, and then the element is retrieved. If we increment, so if we increment here, and we are at index 0, our starting point, that index will be changed to 1, because it was 0 plus 1, 1, and then now we'll be retrieving the element at index 1, and we'll be skipping the element at index 0, and then we return that element. If we increment here, we'll retrieve the element at the current index, starting point being 0, so we'll be able to get that first element. And then before we exit this function, we'll change the counter to 1, and then we return the element. So I think based on what we are implementing, I think that can be the right implementation. Otherwise, if somebody in the audience thinks we should have it, if we have index plus equals 1 at the top and then you retrieve the element, feel free to comment. I hope that's clear. So now we should have a complete iterator. We have implemented the hasNext function, we've implemented the next function, and we've gone to our freezer collection, and we are returning that freezer iterator. So yeah. So just a small problem, not really a problem, but we've changed our contract a bit. So our freezer iterator now has a constructor that receives the elements. So in our freezer collection, we need to pass in those elements. And we don't need to dream up the elements, because the same elements that are used inside the collection are the ones we'll be iterating over. So the ice cream that's inside the freezer is the one we'll be retrieving. So we don't need to create a new list of ice cream instances. So the ones inside the freezer are the ones we are looping through. So when we return an iterator from our collection, we just pass in the elements that we already have inside the collection into the iterator. So when we give somebody this iterator, it contains the element that you can loop over, already wrapped inside that iterator. So now you can loop over them with no stress. Any questions so far? Okay, I believe that means I'm still preaching to the choir. So, but if you have a question, feel free to ask. So let's see how this can be used. So we go back to our collection phase, and we've seen how these other functions work. So what I'm going to do is I'm going to get rid of some of these, trusting that we haven't changed the contract to break any of that functionality. In fact, before I remove them, let me just run it to make sure that we haven't broken any of the functionality. So everything else still works as expected. For now, allow me to remove it so that we're able to have a sort of a clean slate. In fact, instead of removing, for anybody who will be looking at this code later, let's just comment it out. We'll use the same ice cream list that we used. And what we're going to do is obtain an iterator. So get an iterator. I want to iterate through this the proper way. And this iterator will be from our freezer collection dot iterator. So you obtain it from the collection itself. Always remember this, the collection wraps the iterator. So if you want to obtain an iterator, don't create your own iterator. Call the collection, tell it, give me your iterator, because the collection interface dictates that you must have an iterator. So give me your iterator. I want to use it to loop through these things. And the way the best way to use this iterator is to use a while loop. The reason why a while loop is great for this is if I did a while true here, I would be able to create an infinite loop. And this infinite loop would be able to, let's say this inf loop says we are in infinity. I hope my system won't crash. So with that, if I run this, you'll see that runs indefinitely. So it's not conditional. The reason why this is useful, we don't know the bounds of this iterator. It doesn't come with size predefined. So it's not limited by size. So when we use a while loop, we're able to start from an open position in that we don't know the bounds, so you just start iterating. The same different with the for loop. The traditional C for I is equals to this, I less than. That is bound by the index of I. But with the iterator, we don't know the bounds. We don't know how far this index goes. We're in the dark, essentially. So that's why we use a while loop. And what a while loop will be running, it will be running as long as has next returns true. And remember our implementation of has next, it's checking whether there are still elements to loop through. So it's checking, this next index, is there still an element? So as long as that has next is returning true, we can run our loop inside this iterator. And now, this also ensures that this loop is not infinite. So yeah, so while iterator.has next, we can go here and say var element, which is the element at the current index in the iterator, is iterator.next. So check, we do has next, tells us there's an element we can use. We call next, retrieves that element, and now we can do something with the element. Let's say in this case we just want to print it. We don't have something very interesting to do with it. So element is element. Let me call get name because that's accessible. So element is that element. So we expect that this loop will run as long as has next as a value, and next will give us the value at whichever index we are in. So if we run it, array index, so I'm saying out of bounds for length. So this is a typical problem. Let's see. First of all, let me explain it. So the error we are seeing, this index out of bounds, it means we iterated up to index 5, but remember arrays are 0 indexed, so there is never an index 5. So we need to figure out where we're going to index 5. So let's go back to our iterator, and we are iterating as long as index is greater than element. So we are iterating as long as, index, if index is greater than elements.length, then return false. This elements.length can give us 5. It has 5 elements, so it makes sense. So let me just clarify that. So here we have 1, 2, 3, 4, 5. So we have 5 elements here. That is 5 elements. But our array is 0 indexed. If it goes up to 5, there is nothing, because this is index 0. This is index 1. This is index 2. And this is index 3. And of course, the last one here, before my mini here, this is index 4. So if we check for 5, we won't find anything because 5 doesn't exist. So what we need to do is refactor this iterator, this check. And the way we can refactor it is we can say as long as index is greater than or equal to. As long as index is greater than or equal to element.length, return false. So that means if we pass in 5, and so if the index is at index 5, so this index is at 5, then it is equals to length of the elements, because the length of the elements also is 5. So we also have 5 elements in this array of ours. So at this point, it will be 5 equals 5, and we will be able to return false. Previously, we were only checking for starting from 6 onwards. So if you pass in at index 5, here 5 is not greater than 5, so we'll return true. So that is the error that we had. This should be the fix for it, which is making sure that if the index is the same as the size of the elements, still return false. because that index does not exist in the array because arrays are 0 indexed. So we'll run it again and see. So here you can see element is strawberry, so it went to strawberry, it went to vanilla, it went to chocolate, which is this one, it went to blackberry, and then it went to blackcurrant at the conclusion phase. So now our iterator is doing the job that we expect it to do. It's able to loop through a list of elements. The ID is suggesting something here. Okay, yeah, so it's saying we can replace it with an asked for, but we probably don't need to. But I'm curious. Let's see the ID's version of this. Okay, this would not demonstrate the thing we are trying to learn, although we were already using that here. If you guys remember. But this is essentially how you work with iterators. This is very important because a lot of APIs within Java depend on this, and you need to know how to work with iterators for you to work with some of those APIs. Just naming one out of the top of my head is JDBC. So JDBC really depends on this iterator pattern for something called result set that we will cover later. But essentially what I mean is real-world use cases are available for this, and also for your own use cases you can use this to iterate through an array, a collection. In this case we've wrapped an array inside a collection, so there's that, but you can use this to iterate through your collections. So that means we've covered what we intended to cover today. Let me open the floor for questions. Any questions about iterator, creating your own iterator or collection? Oh, this was too easy. Maybe we should have skipped it. Anyone? People are quiet today. I'm assuming it's the call. Kennedy, any thoughts? Steve? Rosemary, did you get the lesson? Were you lost? Okay, so if there are no questions, maybe we can just go ahead and conclude. I'm assuming there are no questions because everybody has understood what we've covered. Just a few things. So I can go ahead and re-enable this, but you can find the source code that we used for this on GitHub. We always back up the source code. And if you have any follow-up questions, of course, if you are not already in the Kenya Java User Group WhatsApp group, this would be a good time to join that WhatsApp group where we have some interactions there. So today we're able to cover Iterator Interface, and we're able to make our collection generic. So you can have access to this source code, go through it at your own free time. If you have any questions that you might want to ask, reach out to me or to any member of the community, and I'm sure they'll be able to assist you. I'll just share the GitHub repo here. So this is the GitHub repository, and the source code has been backed up there. So you'll find it under the collections class. Yeah. If anybody is watching through YouTube, just go to github.com/samuelaguino/kjackjbe, and you'll find all the backed up source code. Okay, so I think I can let you guys go then if there are no questions. Next week, we'll be looking at collections that have been implemented by the Java development kit, or the Java language itself. We look at a few that map to real-world data structures like lists, map, and dictionaries, and sets. So that will be the thing we'll be doing next week. So we won't be implementing our own collection. We'll try to use someone else's collection next week. And I think that will be fun. Okay, have a good one, guys, and goodbye. Awesome.